Welcome, welcome. We're going to do 186 and 187, so here goes nothing. 186 states a student is assigned a project in stats class. The student uses the internet to find the data from the census. So the word census means to literally count every single one. So based on the census list, we arrive at the population for each state. So you think Alabama, Alaska, Arizona, Arkansas, there's a population, Alabama, Alaska, Arizona, there's a population listed at the end of the census for each state. And the student, it says, computes a 90% confidence interval for the mean population. The student stat teacher marks this wrong. Why would that be wrong? So I think it should make sense that, let's say there's 10 million in Alabama and 2 million in Alaska and 15 million in Arizona. These are actually census numbers. I'm not sure why you would do a confidence interval here because you're not going to take a sample of a census. You already counted every single one. So that's what's going wrong here. A confidence interval would not be constructed if we know the population data. We actually, if we don't know the population data, we use a confidence interval to approximate this number. But if we do a census and we arrive at this number, we arrive at this number. I don't know. Interesting question. Now let's go to 187. It states a survey of a total of 259 families was made to determine their vacation habits. So it looks like this is some categorical data that was collected in a two-way table to show where they lived and the length of their vacations. Now, I'm going to just go ahead and box out our raw data. That's our raw data. And so we can think of those as actual people. This is the 259 people standing here. And these are the people that are rural and 1 to 7 days. So this is our and, right? Each of our locations. And these are just my subtotals here. So it says, what is the probability that a randomly selected family was suburban given that they spent 8 or more days on vacation? So given that they spent 8 or more days on vacation, these are the only people I'm going to put in my bag. So as we actually reviewed today, the given part goes in my denominator. Given that they're 8 or more days are these people, and we know that that's a total of 103. So given that they spent 8 or more days on vacation, what's the probability that it was suburban? So we're looking for the value of suburban and suburban. And I can't put this suburban because that's the amount of suburbanites from that. So that's 32 out of 103. And that is approximately 0.31, which is my answer for B. Let's go ahead and stretch this to one more question. 88. A large bakery has many different products for sale. Suppose that 70% of all of the customers bought donuts, 50 bought cinnamon rolls, 40 bought both. So this is another probability, and I'm going to make a table of my own. And again, for ease of use, I'm just going to assume we had 100 customers to make the math easy. So it says they either did the donuts or did not do the donuts. They either ordered the cinnamon roll or did not order the cinnamon roll. And so let's project out some of our data here. Now it says 70% of the customers did the donuts. So let's do 70 out of 100, okay? Now 50% ordered cinnamon roll, so that'd be 50 out of 100. So 40 did both. So donut and cinnamon, that's 40. Now using this idea of complement rule, I can fill in this missing information. So this would be 30, 30, 10, 20, 50. Again, double check and cross check so that all the numbers add up, makes sense. Now they've asked us to calculate, and again, just like the last question, focusing on this raw data now, the idea of percent or proportion would be, we don't know that there's 100, but we know 40 out of 100, and that's 40%. Okay, so if a customer is randomly selected, what's the probability she ordered neither donuts nor cinnamon rolls? So that would be these 20 out of a total of 100 customers, which would be 20%. Our answer then would be choice B. Thank you for joining us.